Hi guys, so we are on 2.8, curve fitting with quadratic models. We're almost done with chapter 2 and I am so excited about that. The first part of today, we're going to be talking about identifying quadratic data, and we're going to be identifying that data from tables. Like, we're going to be able to see if this table, which our tables will be ordered xy pairs, if they represent a quadratic function. So first, the top of your notes, we talk about this. For a set of ordered xy pairs with equally spaced x values, so that every x coordinate in your data set is equally spaced, we'll model this in a minute, with equally spaced x values, a quadratic function, so it can be a quadratic function if it has constant, non-zero, second differences. You probably don't know what that means, but I'm going to show you. It'll be okay. So we can basically write the steps that we're going to have to know, like just from this little definition alone, because so it has to have equally spaced x values, and then so in order to find the second difference, we have to find the first difference. We need to find the first and second difference. And then if all of those are true, then it is a quadratic function. I will show you what I'm talking about. I want you guys to write in these on that top table and your notes as well. Okay, so what I want to do is I'm going to show you what equally spaced x values means and what the first and second differences are, okay? So equally spaced x values, we're just going to look at that top row, which is our x values, and then we're just going to see, what is the difference between these? -3 and -2, that has a difference of 1. -2 and -1, that has a difference of 1. -1 and 0, difference of 1. 0 and 1, 1. 1 and 2, 1. And 2 and 3, difference of 1. Okay, so since all of these are constant, this shows equally spaced x values. So then, since we have equally spaced x values, we can go on. And now we look and we want to find our first and second differences. And that's going to deal with this down here. We're just going to go like this and see what is the difference between these two numbers. That is 5. What is the difference between these two numbers? 3. These two? 1. These two? 1. 1 and 4? 3. And 4 and 9? 5. Okay. So this, what we just did here, that's called the first difference. Oh. And now we're going to find our second difference. Okay. So we just go to all the numbers that we just found there in that first difference, and then we see what the difference is between those. So what is the difference between 5 and 3? 2. Between 3 and 1? 2. Between 1 and 1? That's 2, because you got a 0 in the middle. 2. 1 and 3? 2. 3 and 5? 2. So our second difference is this right here. And a minute ago when we were talking about that, so we have a set of ordered xy pairs with equally spaced x values, and so for it to be a quadratic, it has to have constant, non-zero, second differences. So this is a quadratic function, which we know that because it says right there, but normally that's going to be a y. So I think that let's write down what our steps are. And I'm going to do that right here. And then we will go on to, or let's write down what our criteria is, and then we will go on to solve a few of these. All right, so I just sketched these down, and I want you guys to do the same, because we just talked about them. This is the criteria that we're going to have to meet in order for our data to be a quadratic function. Number 1, does it have equally spaced x values? If yes, then we're going to go ahead and find our first and second differences. And so is the second difference a constant, non-zero value? If it is, that means it's a quadratic. If it's not, then it's not a quadratic. Simple enough. And I know you guys probably noticed that your notes have kind of changed since last time, and we have that column on the right hand side. That's where I want you guys to be writing in your steps, because I understand that I am doing just like a lot of problems and stuff in your notes, but you guys need to know the steps that you're taking and why you're taking these steps. So that's why I put that column in there, and I need you to fill that out. So like this is the type of thing that can go in there, and then you can answer these questions, so that you guys are able to develop this process when you're working on these problems on your own. So let's look at the first one, and we're going to determine whether the data set could represent a quadratic function. I'm just going to keep this little guy over to the side here for reference. Okay, I have our data set here, and so the first thing, does it have equally spaced x values? I don't know, let's find out. So we're going to look at our x values up top here and see what the difference is between each of them. So between 1 and 3, that's going to be a 2. 3 and 5, a 2. 5 and 7, a 2. 7 and 9, a 2. So, does it have equally spaced x values? Well, yes, it does. So then, if yes, we're going to go ahead and find our first and second differences. So, I'm going to find my first difference. Now I can look at between -1 and 1, my difference will be 2. I like to put the arrows there so I know which numbers I'm talking about. Between 1 and 7, 6. Between 7 and 17, 10. Between 17 and 31, 14. Okay, so now I'm going to go ahead and find my second difference. And I'm just going to look here. 2 and 4, 4, 6 and 10. 4, 10 and 4, 4. All right, so now let's look back over here at our criteria. If yes, find first and second differences. We did that. Ow, that hurts. So is the second difference a constant? Yep. Non-zero? Yep. Then that means that this is a quadratic, because the second difference is equal. So this is a quadratic. All right, let's do another one. Well, whether the data set could represent a quadratic function. Okay, first step, does it have equally spaced x values? Let's take a look. 3 and 4, difference, 1. Difference between 4 and 5, 1. 5 and 6, 1. 6 and 7, 1. Yes, we have equally spaced x values. So now, we're going to find our first and second difference. First difference, 1 and 3, 2. 3 and 9, 6. 9 and 27, 18. And then 27 and 81, 54. This isn't looking too hot, folks. Second difference. Difference between 2 and 4, or 2 and 6 is 4. 6 and 18, 12. 18 and 54, 36. So we found our first and second differences. And is the second difference a constant? Nope. Non-zero. Well, it's non-zero, but it's not a constant. So this is not a quadratic.